So here we have our final project for ECE 2001W. We have our iPod input here, we're playing Don't Stop Believin', and we have our microphone input here, and they both come into the operational amplifier here, and they're dampened at different levels to get their voltages at the same amplitude before that. And from there they go out into a bias T through DC offset and into the operational voltage of the laser. And down onto the other side. We have the signal received into a solar cell, and that goes through a potentiometer and op amp to create a controllable volume through the speaker. And from here we're shooting at 80 feet, we counted it out on the floor tiles, and I'll go talk on the microphone to have that out.
Yep. Yeah, it's good.
Alright, so now we have a somewhat watered down schematic of our circuit for the laser transmission. We have our iPod and microphone inputs here. And each of them go through a capacitor to protect them from DC backflow, and then they go through these two resistors which dampen their amplitudes. After going through these resistors, the goal is to have the two waves be of about the same amplitude before entering the op amp. Also with these resistors is they determine the gain values, and that's in respect to this resistor. So for the iPod input, we used a resistor that was slightly larger than this one to dampen it, because we didn't really need to amplify that. And for this resistor, it's much smaller in relationship to this. Going into the op amp, we found it simpler to run 0 and 9 volts across. So we could just plug this to ground and this to a power rail. But the only way we could do that with these inputs, which were oscillating around 0 volts, was to put a 4.5 volt offset into the positive terminal, and we just used the voltage divider off of our 9 volt rail to do that. Coming out of the op amp, we use a larger capacitor to prevent DC backflow once again, and this is the bias T structure here. With our offset, as this takes away this offset, we have to put it back in to activate the laser, and with the inductor and the resistor to monitor the charge there. And the laser projects the charge to the solar cell. This is a somewhat well-drawn graph of what our signals came in as. So this slightly larger wave down here is our iPod input, the smaller one's the microphone input, and after dampening them to the same level and then bringing them up into the operational range of the laser out of the op amp, this is what the signal that's transmitted should look like, and that's what our simulation data looked like. And when we actually got it working and playing out the speaker, that's what it was coming out as.